This video is going to show you how to do ray diagrams for converging lenses. A converging lens has convex faces, and unlike a mirror, the light doesn't bounce off, but instead can refract through the lens. Now notice our setup is a little different from before. We still have our principal axis, that is our horizontal line, and where the middle of the lens meets the principal axis, we call this the vertex still. Our focus is now located on both sides of the lens, and this is because the light passes through rather than reflecting off. We also have something called 2F, or 2 times the focus, and it's basically the length of another focus away from the lens. So it's another way of measuring where our image is going to show up. So when drawing the ray diagram, we follow similar steps to what we did with our mirror. We're going to be taking the top of our object and going, instead of through the center, through the vertex of our lens and passing right through. So I'm going to go from the top of my object through the vertex, and I can take it right through. The line is not going to bend because the light ray will not refract through the middle of the lens. Our second line that we're going to draw will be parallel to the principal axis, and we're going to stop once I hit the middle of the lens. Oops. All right. So again, I'm drawing my arrowhead, stopping midway through the lens, and since we've gone parallel to the principal axis, we now have to go through the focus. And we'll be hitting the focus on this side of the lens because the light ray that's traveling parallel will refract through this lens and bend down towards the focus. So going from the middle of my lens where the light ray penetrated, we're moving down through the focus, and I'm going to make sure I have my arrows drawn. Third and final line will be through the focus and then parallel to the principal axis. So from the top of my image, I'm now using the focus on this side because the light ray will hit that first, and then it will hit the lens. Once again, I'll stop halfway through the lens and have my refracted ray bend parallel to the principal axis. Okay, as we can see, all of our light rays are concentrating right here. So this will be the top of my image. The bottom of the image is always on the principal axis. So as we can see, our image has been flipped on the other side. So now we have to do our salt. The size of our image is smaller than that of the object. The attitude is upside down. The location we will have to be a bit more specific about because this isn't just a case of being on one side of the mirror or the other. We actually have our image between our F and our 2F. And this is on the side of the lens that is opposite that of the object. And because it is on this side, it is considered a real image. If you find that your light rays simply aren't lining up here, you can extend these refracted rays backwards using dotted lines. And if they end up crossing each other and creating an image, then anything on this side would be considered a virtual image. So once again, this is a converging lens. Give these a try, and I'll see you when you're doing diverging lenses.